Everyone. Let me start with a simple question. Have you ever wondered why AI makes certain decisions? Like when Google Maps suddenly changes your route, or when a loan applications get rejected, or when a game AI predicts your next move. Here, the problem is we see what AI does, but we don't know why. And that's where today's topic comes in. Explainable reinforcement learning, or XRL, a major step towards trustworthy AI. Now, coming to our slide. So, in this slide today, I'll be presenting on explainable reinforcement learning, a latest advancement in trustworthy AI. The core idea is simple. AI should not just act intelligently, it should also explain its reasoning. This problem is not just technical, it's personal. Every day, we interact with AI systems, navigation apps, recommendation systems, financial decisions. But when these systems don't explain themselves, it creates confusion and mistrust. People start guessing reasons, which can be wrong. And this leads to poor adoption, especially in critical fields. So now moving on to the next slide, which represents reinforcement learning is widely used today in autonomous vehicle, trading system, even healthcare. But the issue is these systems are black boxes. We can see the output, but the internal decision making is hidden. This creates problems in safety, accountability, and regularity approval. Now, as we can see in the next slide, here let's understand the difference between RL versus XRL. What these terms exactly means. Let's understand the difference. Traditional reinforcement learning learns using rewards, trial and error, and focuses only on performance. But XRL goes one step further. It not only learns but also explains why it took a particular action, like a student showing steps instead of just the final answer. Now we can move to the next slide, which shows us several techniques used in XRL. First, causal maps. These show cause-effect relationships. Second, attention heat maps. They highlight what the AI focused on. Third, reward decomposition. It breaks down why a decision was made. For example, safety versus speed versus efficiency. These techniques makes AI decisions more transparent. Now we can move ahead to the next slide, which talks about shape and line. We also use model agnostic tools like shape and line. These help us understand which features influence the decision without modifying the model. But explanation is not just about numbers, it's about translating them into a human understandable insights. So what and how the things work behind the scenes are explained by these models. Now we can move ahead to the next slide, which talks about accuracy and accountability. XRL is especially important in real-world application. For example, in healthcare, doctors need to understand AI diagnosis. In finance, decisions must be auditable. In autonomous system, explanations help in safety and debugging. In education, AI feedback should be explainable. So trust comes from combining accuracy with transparency. Now we can move ahead to slide 8. This is the main and important slide which helps us to visualize how the things work in XRL. Here we have a simple demonstration, an RL agent which is trained on a small 3x3 grid. We analyze Q values, which represent how good each action is. Using a heat map, we can visualize the agent's preferences. This helps us understand why certain actions are chosen and where uncertainty exists. Even though it's a small example, the concept scales to complex systems. Now we can move ahead to the challenges. So these are the challenges and unresolved mysteries. Despite progress, XRL still faces challenges. Over-reliance, explanations may look convincing but be misleading. Model-free systems, hard to interpret internal logic. Self-explaining AI. Can AI truly explain itself reliably? Counterfactuals, explaining what if scenarios is still difficult. These are active research areas. Now, moving ahead to the next slide, which explains about the future of AI. The future of AI is not just intelligence, it is communicative intelligence. AI must not only perform well, but also explain itself clearly. An AI that cannot explain is like a genius who cannot communicate. Powerful but not trustworthy. XRL is the bridge between the performance and trust. Now, moving ahead to the last slide and concluding today's video, that will be XRL is considered a major advancement because AI systems are becoming more complex and black box regulations now require explainability. It integrates with modern technologies like generative AI, LLMs, and autonomous systems. So XRL connects high performance with human trust. To conclude, AI should not just give answers, it should also justify them. And explainable reinforcement learning is a crucial step in that direction. Thank you.